eBGP neighborship or external BGP neighborship. In this video, I'm going to talk about eBGP and the neighborship of this protocol. BGP, same as eIGRP and OSPF or ISIS, first should establish neighborship. After the neighborship, it can send or advertise routes or BGP updates from one router to the another router. This is the process. Look at here. For example, we have R1 and then R2. R1 in the AS 65000 and R2 in the AS 65001. R1 wants to send network A to R2 with BGP update NLRI equal to net A, and pass attribute, for example, AS pass attribute is 65,000. Because R1 should send this update to R2, first it should check some parameters, some needed parameters with R2. Because of that, before the advertisement of this BGP update, first R1 and R2 should establish a neighborship between them. For example, we have eBGP neighborship between R1 and R2 after some process, and then R1 can send this update to R2, and also R2 can send other updates, other BGP updates to R1. This is needed for checking, for ensuring the good situation, good condition between R1 and R2. We have neighborship conditions, neighborship parameters in BGP, and I want to talk about this. But how neighborship is established and how neighborship is configured. For configuring the neighborship, we have an easy task. In every router, for example, router 1 or router 2, you should configure this command: router BGP AS number. This is the AS number of the router. This is the local AS number. And then you experience the router config router mode. Okay? You should use the neighbor command, neighbor IP. The neighbor IP is the IP address of the neighbor. For example, if we use, in this example, 10.120/24 as subnet between R1 and R2, and the IP address of R2 is 10.122, we should configure here neighbor 10.122, and then remote AS. Remote AS, and finally remote AS number. This is the AS number of the peer. For example, for R1, remote AS number that should be configured is 65,001. Okay? And finally, after you configure this commands in R1 and also R2, the neighborship is establishing, and after that, R1 can send traffic to the R2. For example, if I want to show you here, I should use this configuration: router config, router BGP 65,000. This is the local AS number. And then R1 config router neighbor command 10.122. This is the IP address of the R2, and then remote AS 65,001. This is the configuration needed in R1, and then in R2 config router BGP 65,001 and R2 config router, okay, neighbor 10.121. This is the IP address of R1, remote AS 65,000, and this is the AS number of R1. Okay, so easy. After this configuration, you can check the neighborship with this command: router show IP BGP neighbors, and also this command: router show IP BGP summary. I will explain the difference between these two commands, but you can use show IP BGP neighbors and also show IP BGP summary, but I want to talk about the difference between these two commands. Let's explain some other topics about the neighborship before we configure the neighborship. As you remember, in the previous video, I said that BGP is an application. BGP is an TCP based application with well-known port of 179. You know that if an application that uses TCP wants traffic to send traffic with TCP, first TCP should establish a session with other peer. For example, maybe BGP wants to send BGP update. BGP gives that update to TCP. TCP first should establish a session with other routers, okay? And after that, it can send the BGP updates. Look at here. When you have a connection between R1 and R2, and you configuring neighbor 10.122, this is the IP address of neighbor, a TCP synchronized message sent to the port 179 of R2. This is the for port 179, that is well-known port of BGP, and the destination IP address of 10.122 and the source IP address of 10.121. Why? Because when R1 checks its routing table for this destination 10.122, it can find that the outgoing interface, and after that it should use outgoing interface IP address for the source IP. If you want to check the packet correctly, exactly, this is the packet TCP synchronized, okay, and destination port is 179, source port is random, and then source IP header 10.121 to 10.121 to 10.122. It's so easy, okay? When R2 receives these packets and R2 has configuration, R2 should answer. But if you didn't configure R2, for example, in the first part of first instance of configuration, first seconds of configuration, you receive a reset message. Look at here. Assume that R1 has configuration, BGP configuration, but R2 doesn't have configuration now in this time. R2 receives a request for TCP 179 port, but it doesn't configure configuration for BGP. Because of that, R2 sent a TCP ACK reset message. ACK means I received your TCP SYN, but please reset it, please forget it. Why? Because I don't have configuration for the TCP 179. Because of that, finally the TCP session doesn't establish, okay? But if R2 has good configuration, correct configuration, after it received the TCP synchronized from R1, it should answer with a TCP SYN ACK message. TCP SYN ACK means I received your TCP SYN, and also this is my TCP SYN, okay? From 10.122 to 10.121. Finally, R1 should send again a TCP ACK message, and this means that the establishment between a TCP session establishment between R1 and R2 now is okay and in the final stage, and now we have a TCP session. This is before the BGP neighborship TCP session, okay? And now R1 and R2 can negotiate BGP parameters for neighborship. This is the process that we call it three-way handshake. The process of TCP three-way handshake.